Hello everyone. In this presentation we will talk about nitrosamine assessments. Not this time about nitrosamines as impurities in drug products, but where they meet extractable and leachable qualifications for the pharmaceutical primary packaging. As an introduction, I think the issue with nitrosamines is quite well known. It all started in July 2018 with the recall of valsartan, followed by several other drugs, other sartans, but also other drugs. And why is it such a problem? Nitrosochemicals, they belong to the cohort of concern, according to ICH M7. And cohort of concern compounds are classes of compounds for which the general toxicological threshold of concern of 1.5 micrograms per day for lifetime exposure does not apply. So nitrosamines are a class of high potency mutagenic carcinogens. And we need to monitor their concentrations as defined in the current regulatory guidelines. We can distinguish three different categories of nitrosamines depending how they are formed. Either they are formed during the synthesis of a drug substance, and in most cases this is due to the use of sodium nitrite. Sodium nitrite is an agent that is used as a quenching agent for azide compounds. A second category is nitrosamines are as degradation products of the API. I think one of the most famous cases was ranitidine. But there is a third category of nitrosamines where they originate from the packaging, and one of the most famous examples is nitrocellulose containing laminated blisters. Since the recall of valsartan, there is much more attention for nitrosamines as impurities in drug products. So that we need to perform a risk assessment for nitrosamines. And depending on the risk assessment, maybe you need to analyze very targeted and sensitive the presence of nitrosamines in drug substances or drug products. So you need very sensitive analytical methods for the analysis of nitrosamines, where method development and validation is a key process. But in this presentation, we will only focus on nitrosamines in relation to extractables and leachables assessments. A short word on the formation of nitrosamines. Actually, you need a nitrosating agent, the nitrosyl cation, which is formed in situ. When you have a nitrite anion present in acidic environment, you can form nitrous acid, eventually leading to the nitrosyl cation. Second, you also need a secondary amine, and a secondary amine reacts with the nitrosyl cation towards the nitrosamine. So in summary, you need in fact two compounds, the nitrite anion or the nitrosyl cation, and a secondary amine in an acidic environment. What are the possible sources for amines? You have a list of different amines which can be used in the synthesis of the drug product, or it can be solvents used during the synthesis. But we can also think of amines that are used as additives or solvents in the polymerization process. Then you also have the nitrosating agents. For the nitrosating agents, it is less straightforward where they could originate from a material or a material processing process. It's not so straightforward, so I think it's better to assume that the presence of nitrosating agents, that they are present in the drug product itself, rather than originate from materials. But, of course, if they are present in the drug product, together with the secondary amines, they can yield nitrosamines. So this is just a short summary of what has been told. We have a low risk for the formation of nitrosamines when you have a low amount or a low risk on the presence of secondary amines and nitrosating agents. And you have a higher risk of nitrosamine formation when you have a risk of presence of secondary amines and nitrosating agents. Let's first have a look to some historical cases of nitrosamines related to packaging. In fact, it all started initially with work that was performed in the framework of rubber gaskets in inhalation devices. In rubbers, we have compounds called activators or vulcanization agents that are used during the curing or the cross-linking of the rubber. And an example of such compound is a thioram disulfide. And upon applying the heat, some radicals are formed where secondary amines are formed, together with carbon disulfide. And carbon disulfide is also a compound which can be detected with headspace GCMS, which is one of the analytical techniques we will cover in another presentation. The presence of carbon disulfide can be an indirect indicator for presence of secondary amines and subsequent nitrosamine formation. In the next slides, we will see a non-limitative list of such vulcanizers or accelerators that are used for rubber curing purposes. And you see that a lot of these structures, they contain tertiary amines, which after the heat or the heat reaction, they can decompose into secondary amines. We already touched upon it. Another famous historical case related to packaging are the nitrocellulose containing blister foils. A blister foil, in fact, it contains of multiple layers, of which the printing and the lacquer layer are one of the layers. And the lacquer layer, it may contain nitrocellulose. And nitrocellulose in the framework of the nitrosamine formation is the nitrosating agent. Then you also need the secondary amine. And the secondary amines here, they can be present in the ink itself or be present as UV curing agents, of which some structures are shown on the slide. And when performing the printing, obviously heat is applied as well. The nitrocellulose and the curing agents, they can decompose. You can have, and forming the secondary amine and the nitrosating agent, forming the nitrosamines, and on their turn, they can deposit on the pills or the tablets inside the blister. So from these historical cases, and together with the renewed attention for nitrosamines, this leaves some open questions. And still today, I think these are still open questions. What we need to do about other materials other than rubber. Do they have the same risk for the presence of secondary amines? Probably not. But we need to check the known composition of the material to see if any compounds are present that could lead to the formation of secondary amines. How can we assess the risk of the presence of nitrosamines in packaging? Do we need to assess all materials and all the components, or can we be selective? These are the questions we should ask ourselves. Here I will show you what is the possible role of the screening of extractables and leachables for the detection of nitrosamines in the materials of construction for your application. I think many of you will recognize this as a chromatogram. In this case, it's a GCMS chromatogram. And it's just for pure visual purpose. I draw two lines on the chromatogram. The blue line represents the AET, the analytical evaluation threshold. And this is a translation of the toxicological threshold of concern in combination with the maximum daily dose of your drug product. And it means that compounds above the AET, they need to be further evaluated, and compounds below the AET, they don't need to be followed up anymore because we can label them as being safe. However, recall that for nitrosamines, they are part of the cohort of concern for which the TTC and hence the AET is not applicable. So the red line represents the limit of detection of the method, of the screening method, above which you can identify compounds in the analysis with a large enough certainty. So if we look to some of the peaks detected in this chromatogram, some of them are above the blue line, so above the AET, and they need to be followed up and evaluated anyhow. Some of them are below the AET, but above the limit of detection. And there, for these peaks, we want to specifically screen for the amines. And why do we want to do that? For a GCMS screening analysis, we can say that the limit of detection is approximately 30 micrograms per liter for a standard screening method. And that limit of detection is sufficiently low for the detection of secondary amines, but it's certainly not low enough for the detection of nitrosamines. Because they can be present at such low levels, they are not easy to detect in screening analysis. So we should focus on the amines rather than the nitrosamines themselves, because you won't detect them anyway. But for the screening of the amines, we should look above the limit of detection rather than above the AET, which is not applicable. Now let's have a look to some case studies, real case studies analyzed at Nelson Labs. And in the first case study of the analysis of a rubber plug, we first look here to the screening of a 50% ethanolic extract of the rubber plug. And in this analysis, we confirmed the detection and the identification of a compound, N-formyl morpholine. And I admit it's an amide, it's not an amine. And its semi-quantitative concentration was estimated above the AET. And now we will have a look to the analysis, the targeted analysis for nitrosamines in the same extract. And in this analysis, we confirmed the presence of nitrosomorpholine above the limit of quantification of the method. Although the direct correlation is not straightforward or maybe not so clear, there is a very clear link, structural link between the N-formyl morpholine detected with LCMS screening and the nitrosomorpholine detected here with the targeted analysis. In the second case, the sponsor asked us to immediately perform a targeted screening for a set of nitrosamines in a rubber stopper. So we don't have preceding screening data available, but the sponsor informed us about the structure of the accelerator that was used for the rubber curing. In this case, this was the 4,4-dithiomorpholine. And again, here we can clearly see the morpholine substructure in the accelerator. And indeed, in the targeted analysis for nitrosamines, a peak was detected and was confirmed again to be the morpholine nitrosamine structure. So and here you can really clearly see what has been told before about the curing and the degradation of the accelerator leading to the formation of the corresponding nitrosamine. In this third case, which is still a recent case of a ethanol extraction of rubber stopper, where we performed a screening using GCMS. And in the GCMS screening, we confirmed the presence of dibenzyl amine compound. And you can see it's rather a significant peak, so I estimate it was for sure above the AET. Next, again, we performed a targeted analysis for nitrosamines on a 50% ethanol extract of the same stopper. And again, it's a case of the corresponding nitrosamine, so the nitrosodibenzyl amine, which has been detected and quantified in this analysis. So, what are now the potential consequences for the design of an extractables study? When we find secondary or tertiary amines migrating from the material of or the components, you can consider it as a trigger of action. And you need to really be sure that you can identify all the relevant secondary and tertiary amines during the materials research. So a database containing a lot of amines is a key in that process. In fact, we should report all the secondary and tertiary amines found in the screening already above the limit of detection, rather than above the AET. And when secondary amines are present, you can further investigate the material for the presence of corresponding nitrosamines with a targeted sensitive analytical method. In fact, you have two options. You can target the corresponding nitrosamine from the secondary amine, or you can opt for the detection of a broader list of nitrosamines, but still in a targeted way. What are the consequences for the leachable study design? In fact, it's quite simple. If no amines were detected in the extractable study above the limit of detection, there is no immediate concern of nitrosamine presence from the packaging perspective. So there is no direct consequence for the leachable study, but no nitrosamines from the packaging. That does, of course, not mean that nitrosamines can't be present as another category of impurities in the drug product, so coming from the synthesis or degradation of the API. Now, when we should monitor the nitrosamines or follow-up nitrosamines in the leachable study, obviously, if we directly detect nitrosamines during the extractable study, if that is the case, you can consider a change of the material of construction. And if you don't want to change the material, you can still follow up and monitor the nitrosamines in the drug product leachable study. The situation is a little bit less obvious if you detect the secondary or tertiary amines, so the precursors of the possible precursors of nitrosamines, and you don't find any nitrosamines in the material directly, but still they can be formed in the drug product from your secondary amines if you have nitrosating agents present in the drug product. But yeah, still little is known about the formation in the drug product. Are there nitrosating agents present in the drug product? That depends, or that should come out of your risk assessment. And do you have a favorable reaction environment, so acidic enough to form the nitrosamines? I think we cannot exclude that in the future we will need, or there will be a need for a broader targeted method for the specific and targeted analysis of a set of nitrosamines, maybe both in the extractables and the leachable study. And maybe there can be a parallel, or can we learn something from the implementation of the ICH Q3D guideline about elemental impurities? Before the guideline was implemented, in extractable study, you only focused on targeting these elements which are known from the composition of the materials. Maybe we performed screening. And in the leachables study, in fact, you only followed up those elements or elemental impurities that were detected in the extractable study. So you only monitored the relevant elemental impurities as detected from the extractable study. After the implementation of the ICH Q3D guideline, this perception changed. And in fact, now in a typical extractable study design, we will target all the elements present in the ICH Q3D. As well as in the leachable study, you don't focus anymore only on those elements that were detected in the extractable study, but in fact, again, you will target all the ICH Q3D elements, elemental impurities, just to be sure. Maybe it will become the same for nitrosamines. For which regulations are constantly being updated and provided now. So during extractable studies, the situation now is that you only include the analysis of nitrosamines in extractable study when you have a good reason for it. So if you use certain materials, for example, and in the subsequent leachable study, you will only follow up those nitrosamines that were detected in the extractable study. Maybe we will see a change in the future that a screening for a list of nitrosamines, and likely the most toxic ones, that you will need to screen for them in the extractable study. But as well in the leachable study, you will target the same list of nitrosamines just to be sure that your drug product is safe from a nitrosamines perspective. But this is for the moment still speculation, so we will have to see if this really will become in place. To conclude the presentation, from point to point, there is a general concern, everyone knows that, about presence of nitrosamines in drug products. And amongst the potential sources of nitrosamines is the packaging of the drug product. Nitrosamines can be formed due to the chemistry of the materials of construction of the packaging of the drug product. We can ask ourselves, do we know everything now already about the packaging? I don't think so. There has been extensive research performed on rubbers, not so much on other materials or other additives. So in extractable studies, I think we should primarily focus on the precursors of nitrosamines, so the secondary amines or the tertiary amines, which after degradation can form secondary amines. Also, you can potentially monitor the secondary and the tertiary amines during the leachable study. In your drug product, you can have nitrosating agents present, which can form the nitrosamines together with your amines. You can think of including the monitoring of nitrosamines at low levels, in fact, both in the extractables and the leachable study. And we will have to look what the future will bring in terms of nitrosamine analysis in the framework of extractables and leachable qualifications. So with this, I come to the end of my presentation. If you have any questions, you can ask them now in the Q&A session, or you can let it digest, and if you have any questions afterwards, you can always contact Nelson Labs on the email address shown on the screen or the phone number, or you can visit the new academy, the Learning Academy of Sotera Health at soterahealth.com/academy, where you can find much more free content available for you. Thank you very much.